Hello again. In the last class, we discussed about how to find out the moment about how to find out the resultant of two forces and and then we also discussed about how to really find the component. Now let us try to discuss some problem. So the problem will be, let's say, a three-dimensional object which is given like this. You have a force which is acting in this direction. Here, this one is your x-axis, y-axis, and this is your z-axis, and the force along this direction is given at 100 Newton, and the position along this direction is given as, points. This point is basically given by is -1, no? And then you have x which is given by, let's say, 4, and then you will have z as 0. So this point A and this is point B. So find out the component of find the component of force F 100 Newton along x, y, and z directions. Okay. So this is what you really have to do, is you will have to first find out the direction cosines along this direction. So how to do? First of all, the force is along AB direction. Okay. So force is along AB direction. So you will be writing what? B minus A. So this will give you component of this particular thing that we can take. Let's say this is 0, 0, and this is 5. Alright. So if 0, 0, 5 is there, then this is 0, 0, 5 minus 1, 4, and 0. This will give you the component like 1, 4, and 5 is the position vector. It means that it can be written as 1, 4j, and 5k. And I, j, k are the unit vectors along x, along y, and along z direction. Now you have found the position vector. What is the second thing? You will have to find the unit vector along that direction. This should be AB and magnitude of AB. So what is the magnitude of AB? Magnitude of AB will be 1 plus 16 plus 25. So what it will give? It will give you 12, 4, 40. So this magnitude is given for under root 42. So it means that a unit vector along that direction is given by I plus 4j plus 5k 42. Now you have to find out the component of this force along this direction. So how you can first of all express the force F? To express the force F, you have the magnitude which is given. The magnitude of F is given as 100 Newton, and times the unit vector along which it is acting, which is this. Multiply this particular component with J plus K, and basically Fx, Fy, and Fz will form the component of forces of x, y, and z. So This is how you basically try to find out uh, for how basically you try to find out the component of the forces along different directions. Now if you have to find, let's say, second problem, find the resultant of, let's say, point A is acted upon by force F, which is 5 kilonewton, and then you have component which is given by 6 kilonewton. Find the resultant of these two forces. So let's try to find out, and let's say this angle which is given here is at your 30 degree. Okay, so it means that you have to first form the triangle before you can apply law of sine or law of cosine or even the triangular law. So let's try to do it. The first technique is that you have to find technique 1, find fx. So fx I and I. So f1x plus f2x. Let us say this is your f1 and this is your f2. Okay. So f1x will be 0 and this one will be minus 9 13. Okay. So total is given by this, and summation of y will be given by 1 to 2, 1 to 2 is given by f1y plus f2y. So here it is minus 5 and here it is minus cos of 30. Okay, so now if you have to find out the resultant, what you have to do is you will have to write down your this component, which is I is equal to 1 to 2 I is equal to 1 to 2 and tan theta is equal to summation of fi x divided by how you normally try to find out the solution. However, if you want to apply other law like law of sine, what you can do, kilonewton, then you draw this one which is 6 kilonewton, right? And then this line which is your, so basically 150 degree and resultant R. What will be the, let me also find out. And let's say, and this is your 90 degree, this is 90 degree. If you have to find out the resultant of this particular quantity, so what was using law of cosines? What is law of cosines? If it is your, which is 5 kilonewton, if it is your q, which is your 6 kilonewton, obviously the magnitude of these 2 points. So law of cosine says that r square is equal to p square plus q square minus 2 cos theta, and here cos theta is nothing but 150. 5 square, then 6 square, then 5 into 6 cos of 150 degree, and this is what. Now, if you want to apply your like want to apply cosine, this is law of cosine. If you want to apply the law of sine, in that case you need to, let's say, law of sine. Sine. In that case, what is required is first r. So r divided by sine of 150 degree. And since 1 is known, let's say p. 1 is known, it requires that you should also find out this particular angle. So to get that particular angle, that which is given here, you have been given this 5. Okay, so this 30 is given. So what you have to really do is you have to get this angle. Let's say, so this angle is given. 160 degree. So this is 90 minus 30, which is 60, right? And this power is 60. Now, if since what will be this angle? Because but still, one can find this out. What is known is this component, which is given by 6. This component is 5. So what will be this component? This component will be 6 cos 30. This component will be sine 30. So this angle, the angle that you are going to follow, tan theta will be nothing but 5 plus 6 cos 30 divided by 6 sine 30. So after finding out this theta, you can apply, let's say this is your theta. So what will be this particular angle? So P is given as 5 kilometer, right? So one can find out resultant R, which is nothing but R is equals to 5 sine 150 divided by sine and tan theta is nothing but 5 times 6 cos 30. So this is how you can apply different laws to find the components of forces.